Hello everybody. Today we're going to do dividing polynomials. Sorry if you hear stuff in the background. That's two dogs chewing on two different bones. And I'm trying to be loud enough to drown them out. So sorry if you're wearing headphones. I'm very loud today. Let's go ahead and get started. So dividing polynomials, there are a couple of steps. It's actually really easy because all we're doing for dividing polynomials is factoring. We are just factoring everything and crossing out what they have in common. So those are the two steps. Step one, factor the numerator if you can. So that means if you can do magic X, you should do it. If you can do GCF, you can do it. If you can only do one of them, just do the one. So factor it as much as you can. Then you're going to factor the denominator as much as you can. So GCF or magic X, or if it's a special case, don't forget about those special cases. Okay, meaning difference of squares. So just factor top as much as you can, factor bottom as much as you can. Step two is to cancel out the common factors. So basically, what do both the top and the bottom have in common? Cross them out. Usually it's a common monomial, so you might have factored out a common GCF, or maybe when you factored it and you got your two binomials, maybe both top and bottom have the same binomial, so you can cross them out. So that's what we're going to do today. So example one, we need to divide this, which means we're going to factor both the top, 2x squared plus x minus 15, over the x plus 3. So if we can factor the bottom, we should. Now, so let's start with the numerator. Okay, I just write all this stuff off to the side so I don't have to worry about dealing with the fraction until I have it in factored form. Okay, so I've got 2x squared plus x minus 15. So the first thing I need to look for is there a GCF? Well, the first two terms have an x in common, but not all three, so that's not going to work. None of them really have a common factor for the number, so there's no GCF. So I'm going to go ahead and go straight into my magic x. Okay. Now remember, on the top, you're going to do the a, which is the one with the first term, times the c, which is the one in the back. It's negative 30. So 2 times 15 gives you negative 30. And that's what I'm trying to multiply to. Okay? In the bottom, I'm just going to put whatever the number is with the middle term, which is 1 here. So I need to add to that. So I'm trying to multiply to negative 30 and add to 1. So I just start listing the things that can multiply to negative 30. And you should write this out and make a list. So, negative 30 and positive 1 does not add to be 1. 30 and negative 1 does not add to be 1. Negative 3 and positive 10 does not equal 1 when you add them. I might repeat myself, and I do apologize if I do. Negative 10 and 3 does not add to 1. Then the next one would be 5 and negative 6. That gives me negative 1 when I add them. So let's try the opposite numbers. 6 and negative 5 does add to be 1. So those are the numbers that I'll use to fill in this x, which means those are the numbers we're going to use to replace this middle term. So now we have 2x squared plus 6x minus 5x minus 15. So now we have 4 terms. We're going to go ahead and group them. So the last 2 terms get grouped together, and the first 2 terms get grouped together. So now you have to go through and just find the GCF for each one. What does 2x squared and 6x have in common? Well, they're both divisible by 2, because 2 and 6 are divisible by 2, and they both have an x in common. So I'm going to take all of that out. I'm going to take a 2x out. And I don't know what's going to pop up if I click on it. So sorry if I show you too much. I do show you too much. So I take the 2x out, and I'm dividing each one by 2x. So 2x squared divided by 2x, well, 2 times 2, or 2 divided by 2 will give me 1. X squared divided by x just leaves me with an x. Do that same thing for the other one. 6 divided by 2 gives me 3. X divided by x, just they cancel each other out, gives you 1. So no x's for that term. Now for the second group, I can divide both of them by negative 5. I don't have a common x value though. So just -5. So that's what I pull out to the front is the -5. -5x divided by -5 gives me 1x, and -5 divided by, or -15 divided by -5 gives me 3. Okay, so I have, for both of them, I have the x plus 3. That's one of my binomials. The other one is made up of the stuff I pulled out, the 2x minus 5. So this is my factored form. That is my numerator. Okay, now I got to look at my denominator. X plus 3, there's no GCF, and it's not enough to make the magic X, and it's not a special case where the difference is squares. So that's actually prime, meaning it's not factorable, which is good because I just want to leave it as is. So now I'm going to rewrite this in factored form instead of having it in standard form. So I write it out. I got 2x minus 5 times x plus 3 all over x plus 3. Now do you see how they have the same factor? They both have the x plus 3. That means because I'm multiplying and dividing by that same thing, they cancel each other out. So those are gone, which means I'm only left with the 2x minus 5. And that is my final answer. That is division. Just factoring it all and then crossing out what they have in common. Okay? So let's try another example. Sorry again for chewing, and sorry again if I'm being way too loud. It's because of the chewing of the dog bones. So, example 2, divide this. So I've got -4v to the 4th plus 36v to the 3rd minus 56v squared. So let's start with the numerator. I'm just going to write it off to the side. First thing I want to look for is there a GCF? Well, I hope so, because otherwise this is very, very large. Well, if I look at the numbers, -4, 36, and -56, yeah, those are all divisible by 4, so I can pull that out. And then if I look at the variables, this guy has 4 v's, this one has 3, this one has 2. So at a minimum, they all have 2 v's to give. So yes, there is a GCF. And the GCF would be -4, and I'm pulling out a -4 because the front one was negative. So if I pull out a negative number, it'll make it positive, which makes my life a lot easier. So I can pull out -4, and then I can pull out v squared as well, which would leave me with v squared minus 9v plus 14. Okay, it makes my numbers a whole lot smaller, which is a whole lot more manageable. So -4v squared is one of my factors. I'm just going to kind of make sure it tags along. I'm not going to use it at all. I'm not going to multiply with it. I'm not going to divide with it. Nothing right now. It's just going to be at the front of every line. I'm not going to work with it at all. I'm going to work with this trinomial that was left over though. Okay, so I'm going to make my magic X. I'm going to multiply A, which is 1 here, times C, 14. 1 times 14 gives me 14, and that goes in the top. My B is -9, so it goes in the bottom. I need to find two numbers that multiply to 14, but add to -9. So -14 and 1, or sorry, -14 and -1 do not add to -9. 14 and 1 do not add to -9. 2 and 7 do not add to -9. -2 and -7 do in fact add to -9. So those are what I'm going to fill in. Those are the numbers I'm going to replace the -9v with. So now I still have my -4v squared in the front, and I now have v squared minus 2v minus 7v plus 14. Now that I have 4 terms, I can group it. So I group the first two together, and I group the last two together. The first two have a v in common, so I can factor that out. If I take a v away from v squared, I'm left with v. If I take a v away from -2v, I'm left with -2. The second two are both divisible by 7, but because this one was a negative in the front, I'm going to divide by -7. I'm going to factor out a -7. So I factor out a -7. If I divide this by -7, I'm left with v. If I divide 14 by -7, I'm left with -2. Okay? So again, the -4v squared is just hanging out in the front. It's not interacting with the magic X stuff that I'm doing. They have the same binomial, so that is one of my binomials. The other one is the v minus 7 that I pulled out earlier. So now I'm going to write it as factored form. These are the three factors. These are the three things that got multiplied together to create this whole mess on the top. Now I'm going to go and factor the denominator. So the denominator was negative 2v cubed plus 14v squared. Well, both negative 2 and 14 are divisible by 2, but I'm going to pull out a negative 2 because the front one was negative. And I'm just going to make my life easier. That way the leftovers would just be positive. And this guy also has 3 v's, while this one has 2. So at a minimum, I can take out 2 v's from both. So it does have a GCF, and the GCF would be negative 2v squared. I would be left with 1v from this guy, because I only took 2 away, and this guy would become negative 7. So now I'm going to go ahead and write it in my factored form, which is just writing out all the factors for the numerator and denominator. Now, if you look, they both have a v minus 7, so those will cancel out. Whoa, clicked a bunch of stuff. Those will cancel out. The v squareds cancel out. And then I have negative 4 over negative 2. Well, negative 4 over negative 2 simplifies, like, it just becomes 2. Okay? So all that 2 goes away. I'm left with 2 there, and I'm left with the v minus 2. So 2 from this guy, because I divided that, and I simplified that for the negative 4 over negative 2. I'm left with 2 from that, and I'm left with the v minus 2 from the back. So that is my final answer. Okay? Next one. Find the quotient of y squared minus 4y plus 4 and y squared minus 4. Quotient means to divide. Okay? Quotient is the answer you get when you divide. So basically it's saying find the answer when you divide this guy by this guy. You always put the one that's first on top. So I'm just going to write it as a so it looks like a fraction, so I can tell it's a little bit easier then. So I have y squared minus 4y plus 4, and y squared minus 4 on the bottom. So I'm going to start with the numerator. I look for a GCF. I don't see one. I know I see a bunch of 4's and a bunch of y's, but nothing that's common for all three. So I'm just going to go ahead and make my magic X. So a is 1. It's the invisible 1 here, and c is 4. So a times c is 1 times 4, which is just 4. The b would be the negative 4 here. And I need to find something that multiplies up to positive 4, but adds up to negative 4. Well, 2 times 2 multiplies up to 4, but that adds to positive 4. So I change the signs. Negative 2 and negative 2 will multiply up to positive 4, and they will add to negative 4. So that's what I'm going to fill in my x with, and that's what I'm going to replace the middle term with as well. So now I have y squared minus 2y plus 4. So I'm going to go ahead and do my grouping. Group all these suckers together. The first group has a y in common, so I factor that out. I get y minus 2. The second group can be divisible by 2, but I'm going to take out a negative 2 because this one was negative, and I'm left with y minus 2. So my factored form is going to be the y minus 2 they have in common, and the y minus 2 that I pulled out. Okay? Now I'm going to go do the numerator. Or sorry, I just did the numerator, the denominator. Is there a GCF? Nope, nothing in common between the y squared and the negative 4. So there's 2 ways you could do this. This is actually a difference of squares. Y is squared and 4 is actually a perfect square. So I could do the shortcut, but I'm going to show you how to do the long way, and just so in case you forget to do this. So this one, you're missing your middle term, your b term, so you can fill in a 0y in the middle, and then you can go ahead and fill it in. So you could do your magic X. So I'm going to do a, which is 1 times c, negative 4. 1 times negative 4 gives you negative 4, and b is 0. So I need something that multiplies up to negative 4 but adds a 0. Well, that would be 2 and negative 2. That multiply up to negative 4 but adds 0. So I replace my middle term with a positive 2y and a negative 2y. And now I just go ahead and group like I normally would. The first group only has a y in common. So that would leave me with a y plus 2. And the second group, they are both divisible by negative 2. So I pull that out. I'm left with a y plus 2 as well. So y plus 2 is one of my binomials, and the y minus 2 that I pulled out is my other one. Which, if you knew the shortcut, though, you could have just gotten here, because one's square root the two numbers, and then put a plus and a minus sign in between. So now I'm going to write it in factored form. And if we look at it, they both have a y minus 2 in common, so they cancel out. Ooh, where'd my thingy go? Alright, which now means I have y minus 2 over y plus 2. Cannot cancel anything else out, because one's a plus and one's a minus, so I just have to leave it as is. Okay? Notice how I'm not canceling out these y's and these 2's, because that's all one factor. I can't cancel it out because I can't cancel anything for division when the operation is addition or subtraction. I can cancel these guys out because I'm multiplying them, like division undoes multiplication, so they'll cancel it. That's why they cancel out. So all undoes each other, but addition and subtraction don't undo each other over division. Okay? So those are your 3 examples. That's all I got for you, I believe. Yeah, that's all I got for you. Sorry this is a little bit longer. It's because I wanted to make sure you guys understood the factoring part that went with it. Division part's cake once you got factoring down. So give yourself a little bit more practice with factoring by doing these. You don't have to do any examples, but you can go online and find some more practice for factoring, and we'll go over factoring some more in class. But if you have any questions, write them down and we can go over it. Otherwise, have a great day. Thanks, guys.